Okay, welcome to Chapter 1. As I kind of mentioned to you guys before, I'm going to be using my lecture notes, not necessarily the book. So let's begin. So on page 1 is the Introduction to Computers and Java. Now, hopefully the Introduction to Computers part is a review, right? I mean, you guys have gone through the introduction PC stuff and perhaps even the first programming class. So hopefully that's a review. So, introduction. What is Java? Well, Java is a general purpose programming language. There's an awful lot of them out there. But this is just a general purpose language you can use to do anything. You could create a business application, create a game. You know, it's not specialized. Its real claim to fame is that it runs on practically any device. I mean, it'll run on phones, it'll run on tablets, it'll run on computers, it'll run on everything. I mean, Java is used in lots and lots of places. I mean, for example, my set-top box for my cable TV uses Java as its application language. Cool. Do you have an Android phone? If you did, all of the applications that appear in the Google Store are written in Java. Yeah. So Java's been around a while, and its claim to fame is that it runs on practically every device, which is pretty doggone cool. And then it talks about why program. Think, okay, that's a strange question. Obviously, PCs can do lots of things, right? Right? You can use it to launch a nuclear weapon, or you can use it to keep track of your bank balance, or you can just use it to kill zombies. I mean, right? They can do anything, but it takes a program to be able to do all those things. So the PCs require somebody write an application or program. Those terms are synonymous to make it do all the things that PCs can do. And so we're going to be creating those applications. We're going to be making it do things. We're going to make it do calculators, and we're going to make it do, payroll applications and that kind of stuff. And then go on to say that programming is both an art and a science. Now, this is true, okay? To be a good programmer, you probably need to have that frame of mind that programmers have. I'm not saying you have to have that to be able to do well in this course. I'm just saying that the art and the science thing, you need to be able to think like the computers think, okay? So the more computer thinking you are, the little bit easier it is to catch some of these concepts. Are you really good at puzzles? Do you like solving puzzles? If you do, then programming is going to be kind of fun for you. If you absolutely detest solving puzzles and get frustrated almost immediately, well, then you're probably not going to have fun doing programming. Okay, so the design of an application, typically you're talking about the logical flow of things. If I'm going to be calculating your pay, I'm going to need to know the number of hours you worked and how much your pay rate is, right? I have to get those in the correct order. I have to have both your hours worked and your hourly rate before I can calculate your pay, right? I mean, kind of makes sense. So the logical flow, you have to be able to do math. You have to think about the appearance of this stuff on the screen. If we're first couple of applications we're going to do are what are called console applications. So there really isn't a graphical user interface yet. We'll get to that later. And then input validation is always a big one. If I'm asking for number of hours work, I'm not expecting a -4, or I'm not expecting 4,000, right? In a single week, that would be a little tough to do. And then you have to think about the output. Okay, so on page 2, hopefully this part is all just a review. They talk about hardware and software. Okay, so pretty straightforward stuff, hopefully just a review. You got the CPU, the central processing unit, and you got main memory, secondary storage, input devices, output devices. Hey, what does secondary storage mean to you? I mean, the people who wrote this wrote this long time ago, where primary storage was memory, and secondary storage was anything other than memory, like paper tape and mag reels and all sorts of other things like that. Today, secondary storage are disks, right? Okay, but don't let secondary fool you. Secondary is not like Oh, they're talking about external media, or they're talking about something that I plug in, like removable stuff, like a USB flash. No, no, no. Internal storage is secondary. And a million years ago, I did a introduction to computers at a senior center, okay? And one of the things we talked about is the language that we use to describe all these things. And I said, okay, how many terms, how many words are there used to describe this thing? I was pointing to the monitor. This is back in the day before flat panel screens. And so, we had screen, and we had monitor, and we have CRT, just on and on. There was about a dozen different names you could call that. And if you stop and think about it, a screen? What am I screening? Wow, screening out mosquitoes? A monitor? What am I monitoring? What, my blood pressure? I mean, none of these words make any sense. A display? Okay, we're getting kind of warm. But there's lots and lots and lots of words to describe these things. And to the novice, the words are kind of confusing because they don't mean anything. Okay. Yes, inside the CPU, they have some internal organization. I'm not going to spend hardly any time on this, but yes, there's kind of a math and logic unit and then a control unit that passes things back and forth. And instructions come in and results come out the other end. So there's a fetch, decode, and execute step. Again, that's kind of boring. I'm moving on. So main memory, one more time. Main memory is random access memory, or RAM. This is the stuff that you go to the store and you buy a stick of RAM, this little guy, and you stick it into your computer. Okay, so random access memory, RAM, has a very, very short attention span. I mean, you turn the computer off and all the contents go away. Okay, so that's why you need secondary storage, because secondary storage survives when you turn the machine off. Cool. The next is how memory actually works behind the scenes. I kind of like this. I kind of consider this like, in the old days when you went to the post office, you had all these post office boxes, on the wall. And so if you were number 12, then, all your mail got delivered to post office box number 12, which is kind of cool. So that's kind of sort of how memory works. It's just boxes that you put stuff in, all right? That's basically, and if you have lots of memory, well, then you have lots of boxes. That's kind of sort of. Now later on, when we start using memory, we're gonna create our own boxes, and sometimes a box might be bigger than another box. But for right now, that's a good way of looking at it. Okay, secondary storage. I mentioned that those are disks. So secondary storage would include things like a USB flash drive, or DVD, or internal hard drives, and those kind of things. Input. So input is practically anything. It used to be input was kind of simple. It was keyboard and mouse. Well, then they added touchscreen and voice and fingerprint and facial recognition and all sorts of other things, right, that could be done as input. So I kind of got complicated in a hurry. Output. So the display monitor. That if it's visual, then that's visual output, right? Display monitor. But a printer would also be an output device, right? Cool. And then, of course, software on page 5. So the operating system is part of, that's what basically comes with your computer, most likely. It comes with the operating system. And the operating system is basically the low-level stuff that we're not going to be dealing with much. It's the low-level stuff that makes the machine turn on and, has a user interface and all the rest of that stuff. And they go on to talk about that operating systems are multitasking, which means you can do multiple things all at once, which kind of makes sense. Because, while I'm recording this video, my machine is going out and checking things on the internet and checking this and checking that and, making sure this is happening. There's lots and lots of things going. There's probably, 24 processes running right this very second, even though all I'm doing is looking at a picture. Okay. So the other type of applications are the operating system, then they have user applications. And user applications are what we're doing. This is where, this is the useful apps, right? This is Microsoft Word and, where you're trying to get things done. So the little calculator app that comes with Windows, I don't consider that part of the operating system. Now, it did come bundled with the operating system, but that's not really the operating system. That's just a utility program that is bundled with it. Now, I'm not trying to make you make the distinction between what truly is an operating system and what is not, but just kind of keep that in mind, that not everything that gets installed in Windows is actually part of the operating system. They throw in lots of other things too. So the stuff that we're going to be writing, obviously, is application software, right? We're not going to be writing anything for the operating system. So on page 6, they talk about programming languages. So once again, what is a program? Well, a program is a set of instructions that you write that do something useful. And if that set of instructions is kind of complicated, it's called an algorithm. Now, so for example, if I want to sort something, I might use a sort algorithm. If all I'm going to be doing is, prompting you for the number of hours worked and what your pay rate is, I wouldn't call that an algorithm, although technically it is. Okay? So programs, you either, you can download or you can buy them. They come on, a DVD or whatever. Some of them are free, some of them are licenses, and some of them you out and out have to pay for, right? So there's lots and lots of choices for programming languages. Lots of choices. Whoa, that is not what I wanted to go. Okay, so the common programming languages on page 7. Java is there on the list, and so is JavaScript. Now, I'm going to have a segue here to talk about the differences between Java and JavaScript. So, it sounds like Java and JavaScript are kind of sisters or cousins, or at least somehow related. No, they're not. Not at all. The only thing they have in common is the first 4 letters of their names, and that's it. Okay, now this is a cool story if you're really into history. The Netscape, the people who commercially made the first browser, first commercial browser, they went to this programmer and said, "Hey, can you put together a scripting language for us that works inside the browser?" And it took him 10 days to write this thing. That's pretty doggone amazing. And while he was writing it, had the code name Mocha. And then after that, they called it LiveScript. But Netscape had a licensing agreement with Java because the Sun Microsystems was the people who created the Java language. And they were getting ready to do a great press release about their new product line. And so just as a marketing gimmick, they renamed LiveScript to JavaScript. Now, by the way, they didn't tell anyone when they gave the presentation. Their PowerPoint slides still said, LiveScript on them, even though they had changed the name. I mean, that's how fast the name change took. So LiveScript only lasted like 2 or 3 months, and then it got renamed. Okay, so it is not at all related, not at all. Okay, so moving on page 8, they talk about the history of Java. So it came about with the desire to have something where you write an application and it'll run on any machine. That was their desire, some sort of a universal language that write once and then run anywhere. That was their goal. But at that time, what happened is, if you wanted to run on a Sun Microsystem system, you compiled the application and it ran only on that machine. If you wanted to run on a PC, well, then it would run only on a PC. If you wanted to run on a Mac, it would only run on a Mac. I mean, so that was a tall order. And so what they decided to do was to break up that step. Instead of compiling the application directly into machine code, instead they would compile it into an intermediate step. So they would take the application to an intermediate step, and then the intermediate step would be then further compiled into what the individual specific type of programming language or that the machine used. Okay, we're coming up on the 15-minute mark. So as you probably know by now, that I stopped the video and then start up another one to give you a bathroom break or kitty break or whatever it is. So I'll see you guys in just a few.